This is a technique I use to test and possibly diagnose problems with the attenuators, the 400 series scopes. I've removed the attenuator, in this case it's a vertical mode switch board which has the attenuators on it from a 468. But these attenuators, same attenuator assembly is used in the 465B and in the 475. You can leave, on this side I've left the little attenuator hybrids in. So I'm testing the whole thing with the attenuator hybrids, and at the moment I've got it dialed. Before I forget, you need to temporarily reinstall the input coupling capacitors if you have the unit removed. Otherwise, no signal will get through to the front of the attenuator. And I've temporarily installed knobs so that I can turn the attenuator. And you can see the output on the scope. And I'm going to go, let's see, one step. Okay, I guess I'm maximum sensitivity. I'm on minimum sensitivity. Full counterclockwise. Now as I step the attenuator, also changing the output of the calibrator, but I get continuously output means this attenuator is working fine. The last three steps on the 468 are the 0.1, 0.2, 0.5, or whatever, 0.2, anyway, the high sensitivity sort of digital zoom voltages, so they're all the same. Then less sensitive. So no problems throughout the entire range of that attenuator, which means the attenuator hybrids themselves are also working, are also good shape. And I've connected the scope to the there's a 470K and a 001 cap comes off the attenuator and connects to the FET input of FETs, and I've very carefully hooked onto that right now to get the signal out of the attenuator. But those are very fragile components, so be very careful with that. Now, if you have a problem and suspect the problem might be one of the attenuator modules, then the thing to do is to remove all the attenuators and replace them with wire jumpers. I've put wire jumpers across the middle pins of the attenuator. So we can get a better picture of that. See these small wire jumpers. And these are pieces of wire actually cut off of a long transistor lead. They're very small diameter, about the same diameter as the wire pins on the hybrids. If you use larger wire, you're likely to damage the pins on the attenuator board. Now, I'm going to turn down calibrator output. I'm going to hook calibrator input to this side. And again, I'm being very, very careful to connect to this very small 8 watt resistor and capacitor. Now, since there are no attenuators in the way, the signal is going to be constant. And if it's anything but constant, then there's a problem with the switch. Now, if you suspect an attenuator problem, then you can, that is a problem with attenuator hybrid, these little things. You can install them one by one and then run the switch through, and then you'll have to vary the calibrator input. So let's do that. I'll replace the first jumper wire with the attenuator module. Now, I have the first module in, which is the ×2. So now, when that module comes in, the signal drops by half. But there should always be a signal at every position of the switch. Now I can put in, I'll put in the next one, which is ×4. Oh. Before I do that, I need to take out the wire jumper. Now, as the two attenuators come in to the circuit, so those attenuators are good. Now I'll replace the ×10 attenuator, or reinstall. And now, see, low signal level, bring the calibrator up. But again, a signal at every setting of the switch. Now finally I'll just replace the last one and we'll be back to where we were on the side with all the attenuators in place. Again, signal at every attenuator position. So, I proved that these attenuators are working fine, and I'll feel confident reinstalling this unit back in the instrument it came from. Hope you found this interesting. Thanks for watching.